Welcome students to online classes of mathematics for class 8. In this video we are going to study the chapter number 9, which is algebraic expressions and identities of NCERT textbook. This session number 6 for this particular chapter. Here we are doing the exercise 9.5 and we'll be looking at the remaining question of exercise 9.5, that is from question number 5 to question number 8. Okay, myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The chapter number 9, algebraic expression, we have already covered the first three subtopic of this chapter in the previous session. Here we are studying the fourth one, which is the algebraic identities. Okay, and we have already discussed these four standard algebraic identities in the previous session. Okay, we are going to use these in the exercise 9.5. okay, so let's move to the exercise 9.5 now. This exercise in total have 8 questions. We have already covered question 1 to 4 in the previous session. Okay, so we are now going to start with the question number 5. In question number 5 we have question is, show that we are given the certain equation and we have to prove that the expression given on the left hand side of the equality sign is equals to the expression given on the right hand side of the equality sign when we simplify them. Okay, so we have to prove that in each case the expression on right hand side is equal to the expression on the right hand side, left hand side and left hand side and right hand side are equal. Okay, when we simplify the expressions. Okay, so let's start with the first one. We have here 3x plus 7 whole square minus 84x equals to 3x minus 7 whole square. Okay, so we're going to start with the left hand side term, which is on left hand side we have 3x plus 7 whole square minus 84x. Okay, in this one we are going to use the identity number 1, which is x a plus b whole square. Okay, so we'll write using the identity a plus b whole square, which is equals to a square plus 2ab plus b square. Okay, so that will be equals to, we are going to apply the identity here. So we have this a square, that means a here is 3x whole square plus 2 into a, which is 3x, and b is 7. Then we have b square, that is 7 whole square, that we have minus 84x. Okay, let's solve this now. This 3x whole square will be 9x square, then we have plus this 2 into 3 is 6 into 7 will be 42x plus 7 square is 49, then we have minus 84x, or this will be, we have 9x square, this plus 42x and minus 84x will give us minus 42x plus 49. So that's the simplified form of the left hand side term. Now we're going to do the same with the right hand side term. So right hand side term is equals to, we have here this as 3x minus 7 whole square, that is 3x minus 7 whole square. So we are going to use the identity number 2, which is a minus b whole square. Okay, so write using identity a minus b whole square, which is equals to a square minus 2ab plus b square, that is this 3x minus 7 whole square will be equals to this a square, that means 3x whole square minus twice of ab. A here is 3x, b is 7, and now b square is 7 square. Okay, and this will be, the 3x whole square will be 9x square, and we have minus this 3 into 6, 2 into 3 is 6, and 6 into 7 is 42x plus 7 square is 49. Now as you can see, these two terms are exactly similar. That means hence left hand side term is equals to right hand side term. So this is proved now. Okay, that's what we were asked to prove. We have to show that the both terms are equal when they are expanded. Okay, now moving ahead to the next one, we have 9p minus 5q whole square plus 180 pq equals to 9p plus 5q whole square. Okay, so we are going to again start with the left hand side term, which is 9p minus 5q whole square minus 180 pq. Okay, so we are going to use identity a minus b whole square. Okay, so let's write using identity a minus b whole square, which is equals to a square minus twice of ab plus b square. So this will be, we have this 9p minus 7q whole square minus 180 pq will be equals to, let's apply the identity here. This a here is 9p, and we have minus twice of ab. A is 9p, b is 5q, then we have plus b square, which is 5q square, and in the end we have this minus 180 pq. Okay, or this will be, this 9p whole square will be 81 p square minus this 2 into 9 is 18, 18 into 5 is 90 pq. Then we have plus 5q whole square will be 25q square. After that we have 180 pq. Okay, so that's the simplified form of this expression. Here we have this minus 90 pq, and here we have this one is plus, not minus. Okay, this is plus, and we have this plus 180 pq. So this will result as 981 p square minus this minus 190 and plus 180 will give us plus 90 pq. Okay, then we have this 25q square. Okay, this plus 180 and minus 90 will give us plus 90 pq. So that's a simplified form of the left hand side term. Now we're going to solve the right hand side term. So we have and RHS is equals to, we have 9p plus 5q, 9p plus 5q whole square. Okay, we are going to use the identity using identity number 1, which is a plus b whole square, which is equals to a square plus 2ab plus b square. Okay, so this will be 9p plus 5q whole square will be equals to square of first term, that is 9p whole square, plus twice of ab, that is 9p into 5q, then we have b square, that means 5q square, or this will be 9p square will be 81 p square plus this again 2 into 9 is 18, 18 into 5 is 90 pq, plus 5q square will give us 25q square. Okay, so now you can see these the simplified version of left hand side term is exactly equals to the simplified version of right hand side term. So hence LHS is equals to RHS. Okay, that's the solution of this one. Next is we have 4 by 3m minus 3 by 4n whole square plus 2mn equals to 16 by 9m square plus 9 by 16 n square. Okay, so again we're going to start with the left hand side term. We have this LHS equals to 4 by 3m minus 3 by 4n whole square plus 2mn. Okay, in this part we're going to use the identity a minus b whole square. So I'll write using identity a minus b whole square, which is equals to a square minus 2ab plus b square. Okay, so this will be this 4 by 3 m minus 3 by 4 n whole square plus 2mn will give us, we have a square, a here is 4 by 3 m whole square, then we have minus 2 into a here is 4 by 3 m, b is 3 by 4 n, then we have plus b square, that means 3 by 4 n whole square. Okay, and in the end we have plus 2 mn. Okay, and this will be equals to this 4 by 3 m square will give us 16 by 9 m square. Will be this 4 will be cancelled out by this 4 here, and this 3 will be cancelled by the 3 here. So what left here is minus 2mn, then we have plus this 3 by 4 n square will give us 9 by 16 n square. In the end we have 2mn. Okay, now as you can see this minus 2mn and this plus 2mn will be cancelled out, and what we left with is equals to 16 by 9 m square, then plus 9 by 16 n square, and which is exactly equals to this right hand side term. Okay, this is equals to RHS. So hence proved. That's the solution of the part 3 of question number 5. Now next one we have this, it should be equals to 48pq square. Okay, so we have 4pq plus 3q whole square minus 4pq minus 3q whole square equals to 48pq square. Okay, so we are going to solve this part and we'll check if this is equals to the right hand side term. Okay, so let's start with the left hand side term. LHS is equals to 4pq plus 3q square minus 4pq minus 3q whole square. So here we're going to use the a plus b whole square, and here we'll use a minus b whole square. So this will be a plus b whole square means a square, that is 4pq whole square, plus twice of ab, that is pq into 3q, plus b square, that means 3q whole square, bracket closed. Then we have minus sign, and in the second bracket we are going to solve the second term by applying the second identity, that is a minus b whole squares. Okay, so this will be 4pq square minus twice of 4pq and 3q, plus we have 3q whole square. Okay, so this will be, this 4pq whole square will give us 16p square q square, plus we have this 2 into 4 is 8, 8 into 3 is 24 pq square. Okay, then we have this 3 square is 9, and this will be q square. Okay, then we have this minus sign. After that, this 4pq whole square will give us 16p square q square, and we have minus, this will be again 24p q square, and then plus 9q square. Okay, let's open this bracket now by reversing all the sign inside the bracket. So we have the 16p square q square plus 24p q square plus 9q square. Okay, then we have minus, this will be 16p square q square, it will become plus 24p q square, then we have plus, this will change to minus 9q square. Okay, now as you can see, we have this plus 16p square q square, and here we have minus 16p square q square, so these two will be cancelled out. Similarly, we have this plus 9q square and minus 9q square, these two also will be cancelled out. So only terms that left is this 24pq square and 24pq square, that will be 48pq square. Okay, and which is exactly equals to this right hand side term, this is equals to RHS. Okay, so that's the solution of the part 4 of question number 5. Okay, now let's see the next one. Here we have a minus b into a plus b, then we have b minus c, and this one is b plus c, and we have c minus a into c plus a. Okay, equals to 0. So again we are going to start with the left hand side term. We have a minus b into a plus b plus b minus c into b plus c plus c minus a into c plus a. So we are going to use the identity, which is identity number 3, which gives, using identity a plus b into a minus b equals to a square minus b square. As you can see, in each case we have the two terms, first in subtraction then in addition, again two terms in subtraction and then addition, and in a third case also the two terms are in subtraction and addition. So simply we can use this identity here, that will give us square of first term minus square of second term. So first term here is a square, second term will be b square, then we have plus in between, this will give us the square of first term, that is b square, and minus square of second term, which is c square. Okay, then we have plus, and this term will give us square of first term, which is c square, and minus square of second term, which is a square. Okay, now you will notice that here we have plus a square, here we have minus a square, so these two will be cancelled out. Similarly, have here minus b square and then plus b square, these two also will be cancelled out, and this minus c square and plus c square will also be cancelled out. So what we left with is only a 0. So the result, which is equals to the right hand side term, okay, it is equals to RHS. So that's the solution of the part 5 of question number 5. Okay, now moving to the next question. This is question number 6. It says using identity evaluate the value of these. Okay, so one method is to simply by doing multiplication, but we are asked to use your identity. Okay, the one way of finding the square of 71 is to just multiply 71 into 71, you will get the result, but we have to use the identity to find their solution. Okay, so we can write this one as 71 whole square can be written as, we can write this as in the simplest form is 70 plus 1. Okay, 70 plus 1 is 71, and this whole square. Now we can use identity a plus b whole square. Okay, so let's write using identity a plus b whole square, which is a square plus 2ab plus b square. So this will be 70 plus 1 whole square equals to square of first one, that is square of 70, plus 2 into a here is 70 and b here is 1, then we have b square is again 1 square. So 70 square will be 4900 plus this 70 into 2 is 140 into 1 is again 140, then we have 1 square is 1. Now we have to add all this number, that will be 5041. So that's the solution for this one. Okay, now see, let's next one we have 99 square. Again we have to find a solution without doing the multiplication, that means we are going to use the identity here. Okay, so we can write this 99 as, like in the previous one what we did, this was a 1 above the 70, so we had written as this as 70 plus 1. Now this is 1 less than the 100, so we can write this as 100 minus 1. Okay, we'll look for the next or the closest 10 multiple of that number. Okay, so 10's multiple of this 99 is 100. In the previous case, 10's multiple of 70 is 71 is 70. Okay, so we can write this as 100 minus 1, which is again 99 whole square. So we are going to use the identity number 2, which is a minus b whole square. Okay, we are going to use a minus b whole square, which is equals to a square minus 2ab plus b square. So this will be 100 minus 1 whole square equals to, so we have square of first term, that is 100 square minus twice of first term into second term, that is 100 into 1, then we have b, which is 1 square. So this 100 square is 10,000 minus this 2 into 100 will be 200, then we have plus 1. Okay, now we have to add and subtract this term, so this will be 10,001 minus 200. After the subtraction we will get the result as 9,801. Okay, so that's the whole product of 99 into 99. Okay, now next one is 102. Again you can see this is closer to the 100, so next multiple of 10 or the closest multiple of 10 for this number is 100. So we can write this as 102 square can be written as 100 plus 2 whole square. So now we are going to use a plus b whole square. Okay, so let's write using identity a plus b whole square, which is equals to a square plus 2ab plus b square. Okay, so that means this 100 plus 2 whole square will result as a square, that means 100 square plus twice of a into b, that is 100 into 2 plus b square, which is 2 square. So this will be 100 square is 10,000. This 2 into 2 is 4, 4 into 100 is 400, and this 2 square is 4. So the result for this one is 10,404. Okay, now see next one. Next number is 998. Again, the tens multiple of the closest tens multiple to this number is 1000. So we can write this as 998 whole square can be written as 1000 minus 2. Okay, again we are going to use the identity number 2, which is a minus b whole square. So let's write using identity a minus b whole square equals to a square minus 2ab plus b square. Okay, so that will be 1000 minus 2 whole square equals to square of first one, that is 1000 square, minus twice of first term, that is 1000, into second term, which is 2, and we have plus square of second term, which is 2 square. So the square of 1000 means these 3 zeros will become 6 zeros. So we have 1 2 3 4 5 and 6 0, that is 10 lakh. Okay, and we have minus this 2 into 2 is 4, 4 into 1000 is 4000, and this 2 square is 4. So when we solve this, we will get the result as 996,004. Okay, first you have to add these two, then subtract the 4000 from it, you will get the required result. And moving to the next one, we have here is 5.2 whole square. So this can be written as, this 5.2 square can be written as 5 plus 0.2 whole square. Okay, again since this 5 is less than 10, so we will be looking for the next or the closest whole number. Okay, so the closest whole number here is 5. So we can write this 5 plus 0.2. So this will be using identity a plus b whole square, which is a square plus 2ab plus b square. Okay, so this will give us 5 plus 0.2 whole square equals to square of first term, that is 5 square, plus twice of first term into second term, that is 5 into 0.2, then we have square of second term, which is 0.2 square. Square of 5 is 25, plus this 2 into 5 is 10, 10 into 0.2 will be 2, then we have 0.2 square is 0.4. After adding the numbers, we will get the required result as 27.04. that's our answer. Okay, now next one here is, we have this 297 into 303. So this can be written as, this 297 into 303 can be written as, the closest tens multiple to this number is 300. Okay, so we can write this number as 300 minus 3, so we'll get 297, and second number can be written as 300 plus 3. Now this one is in the form of a minus b into a plus b, so we can use a third identity, which is simply first a square and the b square. Okay, so we'll write using identity a plus b into a minus b, which is a square minus b square. Okay, so it doesn't matter if you write the positive term first or the negative term first. Okay, in multiplication the order of number doesn't make any difference. Okay, so this will be 300 minus 3 into 300 plus 3 will be equals to square of first term, that is square of 300, minus square of second term, which is 3. So square of 300 will be 90000. Okay, then we have minus square of 3 is 9. So after solving this, we get the result as 899 8991. Okay, that is 89,991. Okay, next one is again 78 into 82. Again you can see the closest tens multiple from this number is 80, so we can write this as this 78 into 82 can be written as 80 minus 2 and 80 plus 2. 80 minus 2 is 78 and 82 plus 2 is 82. So again we are going to use a plus b into a minus b equals to a square minus b square. Okay, so let's write using identity a plus b into a minus b, which is equals to a square minus b square. So this will be 80 minus 2 multiplied to 80 plus 2. This will result as square of first term, that is square of 80, minus square of second term, that is square of 2. This will be 80 square is 6400 minus 2 square is 4. When you subtract the 2 you will get 6396, that is 6396. Next one is we have 8.9 square. Simply this, again the closest number to this is 9, so we can write this 8.9 square as 9 minus 0.1. okay, we can also write this as 8 plus 0.9. you can solve it with the both number. You will see that answer for both one is exactly similar. Okay, so I'm taking this one, you can try with this one also. Okay, so we'll use the identity. If you're using this one, so we'll use the identity a minus b whole square, or if you're using this case, and that we'll use the identity a plus b whole square. Okay, so I'm taking this one, so we'll use using identity a minus b whole square equals to a square minus 2ab plus b square. So this will be 9 minus 0.1 whole square equals to square of first term, that is square of 9, minus twice of first term, that is 9, into second term, which is 0.1, and we have plus square of second term. So this will be 9 square is 81. We have minus this 2 into 9 is 18. 18 into 0.1 will be 1.8. Then we have plus the 0.1 square will be 0.01. okay, so when we solve this, we get the result as, first we have to add these two, then we are going to subtract this 1.8. okay, so we get the result as 79.21. so that's our answer. Now coming to the next one, what we have here is 1.05 multiplied to 9.5. okay, as you can see, the difference between the two numbers is very big. okay, so this one is a bit tricky. What we are going to do here is, we have this number 1.05 multiplied to 9.5. from this number 9.5 we are going to take 10 common, so we can write this as 1.05. okay, multiplied to, from here we are going to take a 10 common, we can write this, then this as 0.95 multiplied to 10. So if we multiply these two numbers, we are again gonna get this 9.5, right? So we will be considering these two first number, that is 1.05 into 0.95, and then we have 10 multiplied to the whole number. okay, so we can now use an identity in the first part in this one, that is by converting them in the form of 1 plus 0.05, and we can write this as 1 minus 0.05. so if you add these two, you again get 1.05, and when we subtract these, we again get 0.95, and then we have in the end 10 multiplied to the whole number. okay, so we are going to use a plus b and a minus b identity, which is identity number 3. so let's write using identity a plus b into a minus b, which is equals to a square minus b square. okay, so this will be the square of first term, that is first term here is 1, square, that then minus square of second term, which is 0.05 square, and then we have 10 multiplied to this whole term. Okay, so now this 1 square is 1, then we have minus is 0.05 square will be 0.0025. okay, and then we have multiplied 10. This will be 1 minus 0.005 will result as 0.9925 multiplied to 10, and when we multiply the 10 to this, we will get, it will be 75925. okay, after multiplying 10 to it, this will get 9.975. okay, so that's our answer. Now coming to the next question. Here we have 4 parts. In all the 4 parts we are given that we have to use this particular identity. okay, that is a square minus b square equals to a plus b into a minus b. So these two are given in the form of a square and b square. A square minus b square, we will use this identity to find their answer. okay, so let's start with the first one. We have this 51 square minus 49 square. This can be written as a plus b and a minus b. That means first we are going to add these two terms, that is 51 plus 49, and then we are going to add, subtract these two terms, that is 51 minus 49. okay, so this 51 plus 49 will be 100, and this 51 minus 49 will be 2. So the result for this one is 200. okay, so next one is, now we have this 1.02 square minus 0.98. So again this is in the form of a square minus b square. okay, so we can write 1.02 whole square minus 0.98 whole square. okay, that means again we are going to first add these two terms, that is 1.02 plus 0.98, and then we are going to subtract them, it is 1.02 minus 0.98. so this will be, the sum of these two will be 2, and when we subtract these two, we will get the result as 0.04. okay, so that's the subtraction of these two numbers. When multiplied with these two, you will get 0.08 as the answer for the part second of question number 7. okay, now moving to the next one, we have 153 minus 147 square. So again we can write this 153 square minus 147 square as, first we are going to add these two terms by using the third identity. So this will be 153 plus 147, and then we are going to subtract these two terms, that is 153 minus 147, that is this one is a plus b and a minus b. okay, the sum of these two is 300, and when you subtract this, you will get 6. So 6 into 300 will be result as 1800. okay, now next one is, we have 12.5 12.1 square minus 7.9 square. So we can write this as 12.1 square minus 7.9 square, considering this this is as a minus b whole a square minus b square. We can write this as a plus b and a minus b. okay, so first we are going to add these two terms, that is 12.1 plus 7.9 and 12.1 minus 7.9. so this 12.1 plus 7.9 will give us 20, and this 12.1 minus 7.9 will give us 4.2. so after multiplication we get the result as 84. So that's the answer. Now coming to the last question of this exercise and also from this chapter, we have, using this particular identity, we have to find the solution of these given numbers. okay, so we'll be using this particular identity. So first we have to convert each number in the form of this expression. okay, so that is, we have 103 into 104. This can be written as, we can write this 103 as 100 plus 3, as we should have this x same, so we'll convert the second one as 100 plus 4. Now you can see in both case x is 100 and a here is 3 and b is 4. okay, so we'll write this as using identity the given one, that's x plus a into x plus b equals to x square plus a plus b into x plus ab. So this 100 plus 3 into 100 plus 4 will result as x square, that means 100 square, plus the sum of a and b, that is 3 plus 4 into x. X here is 100. Then we have multiplication of a and b, that is 3 into 4. So this will be 100 square is 10,000. This 3 plus 4 is 7. 7 into 100 is 700. Then we have 3 into 4 is 12. When we add this, we'll get 10,712. That's the answer for this one. Okay, now coming to the next one, we have 5.1 into 5.2. So that is, this can be written as 5.1 into 5.2 can be written as 5 plus 0.1 into 5.0.2. okay, 5 plus 0.1 and 5 plus 0.2. so x here is 5 and a here is 0.1 and b is 0.2. so we will write again using identity x plus a into x plus b equals to x square plus a plus b into x plus ab. so this will be 5 plus 0.1 square, 1 into 5 plus 0.2 will be result as x square. X here is 5 plus we have a plus b. A here is a here is 0.1 and b is 0.2, and then x is 5. Then we have a into b, that is 0.1 into 0.2. okay, now we have to solve this. The square of 5 is 25. Then we have this 0.1 plus 0.2 will be 0.3, and 0.3 multiplied to 5 will result as 1.5. then we have plus this 0.1 into 0.2 will result as 0.02. after adding all the numbers, we'll get the result as 26.52. okay, so that's the answer for the part second of this question. Next one is, we have 103 into 98. so we can write this as 103 into 98 can be written as 100 plus 3 multiplied to 100 minus 2. okay, so again we're going to use the identity using identity x plus a into x plus b equals to x square plus a plus b into x plus ab. okay, so this will be 103 100 plus 3 and 100 minus 2 will be result as x square. X here is 100, and we have a plus b. A is 3, b is minus 2 into 100, which is x. Then a into b is 3 into minus 2. so this will be 100 square is 10,000. then we have this 3 minus 2 is 1. 1 into 100 is 100, and this 3 into minus 2 will be minus 6. okay, when we solve this, we get the result as 10,094. okay, now coming to the last one, we have 9.7 into 9.8. so we can write this as 9.7 into 9.8 can be written as 10 minus 0.3 and 10 plus, not plus, again 10 minus 0.8, 0.2, not 8. we can also solve this in other way, that is 9 plus 0.7 or 9 plus 0.8. you can use any one of the two, you will get the result as same. I'm using this one, first one. You can also try with the second one. okay, So let's take this one. First we write using identity. Okay, in both case you see 10 minus 0.3 is 9.7 and 9 plus 0.7 is again 9.7. okay, so we can use the either of the two. So let's write using identity x plus a into x plus b, which is equals to x square plus a plus b into x plus ab. okay, so that will be 10 minus 0.3 into 10 minus 0.2 will be equals to x square, that is x here is 10 square, plus we have a plus b. A is 0 minus 0.3, b is minus 0.2, multiplied to x is 10, then we have minus 0.3 multiplied to minus 0.2. okay, so that will be 100, or 10 square is 100, plus we have this minus 0.3 and minus 0.2 will be minus 0.5 into 10 is minus 5. okay, so this will be minus 5, and this 0.3 into 0.2 both are in minus. When minus minus multiply, we get it result as plus. So 0.3 into 0.2 will give us 0.06. so after solving this, we will get the result as 95.06. okay, so that's the answer of the part 4 of question number 8. With this we have completed all the questions of exercise 9.5. okay, with this we have completed the exercise 9.5. now you have to practice all these questions multiple times so that you can understand them better. okay, so that's all for now. Thanks for joining here everyone. Thank you.